Get it back in.
Oh, you're not. There's no room. Yeah.
Yes.
What is it?
I know.
Don't worry.
All right, so last part that we're going to talk about with this section is hybrid theory. More particularly, hybrid orbitals. Once again, this is looking at the central atom and looking to see how it's able to bond to different things. So let's kind of start off with a very simple compound.
Can I not spell?
I don't know. Let's look at CH4. Now, just looking at the chemical formula, what is going to be our central atom?
C.
Carbon. Okay, now, throughout the beginning of this process, we said that the electrons that we use for bonding are the valence electrons, right? So if we look at the valence electrons for carbon, let's see, how do do this? How many electrons should I put in the 2p sublevel for carbon?
3. Right?
2. All right, so here's carbon's electron configuration from way back in the day.
I don't remember that.
So, how is carbon able to bond? Well, to bond, it needs to have unpaired electrons. In this electron configuration, carbon is only showing 2 unpaired electrons, right? So what's going to happen is that our orbitals from the 2s and the 2p sublevel are going to combine together to give us a hybrid orbital. And if we count up how many orbitals in the 2s and the 2p, we come up with a grand total of 4. Everybody see that? Okay. So with that hybrid orbital, those 4 valence electrons that carbon has are going to occupy each of those 4 orbitals. Now it's able to bond to 4 different things. Okay. Now this hybrid orbital, what do we call it? Well, we took the orbital from the 2s, so we're going to have an s. Then we have the 3 orbitals from the p, right? So this hybrid orbital is going to be called sp3. What kind of questions do we have about that?
Oh, I got a lot.
Why did 3?
Because we had to use the 3 orbitals from the p sublevel.
Okay.
All right?
Can we do a quick review on how you got the superscript first?
I didn't do superscript.
I'm not superscript, but
Orbital?
configuration.
Well, carbon is the 6th element, so it has 6 electrons. We always start down with 1s. We got to put 2 electrons there. Then we go to 2s. We have to put 2 electrons there.
Makes sense.
Then it's over in the 2p range. And we need 2 more electrons, so 2 electrons will be in the.
Would it work if I just put HE in those brackets and I just put 2S2P?
I don't care. I'm just showing where it's. Oh, it's
Yeah, I don't know how to start, I don't know how to do it. I only know how to.
You always start with 1s.
I only know how to do a shortcut.
You always start with 1s.
I don't know how to do it all.
Okay, any other questions right now?
Pretty good.
No? Let's look at another one. Okay? So what's our central atom in this? Not bromine.
Boron.
Boron. Rhymes with
Oh, yeah.
moron.
Yeah, Jake. Boron.
Hey, how many electrons does boron have?
5.
5, right? So 1s, 2 electrons there, then 2s, we're going to put 2 electrons there. How many electrons in the 2p sublevel?
Uno.
1. Now with this one, we need to have 3 unpaired electrons so it can bond to the fluorine atoms, right? So we're going to take, once again, take the electrons from the valence shell, the 2s. Definitely going to need to have that s sublevel. How many p sublevels are we going to need to have?
2,
Or no, 3.
2.
because you take one of the
Because we already take 1 from the s, then we need 2 of the orbitals from the p sublevel so that we get those 3 unpaired electrons. So this hybrid orbital would be called sp2. Okay? Questions? Olivia? No? No questions? All right.
Okay, but I got a question now.
Yes.
So if you take 1 off of S,
It's getting bumped up to one of the p orbitals.
so if it's getting bumped up to one of the p orbitals, then shouldn't you only need 1 more p orbital? Or 1 more p electron? What are those?
You already have
Like-
one.
What's happening is this, like you said, 1 from the 2s. So it's making this hybrid because we only need the s orbital and we only need 2 of the p orbitals. So it can bond to the 3 fluorine atoms. Okay? Is that kind of helping out a little bit now? Any other questions right now? All right. PCO5. What's our central atom going to be?
Phosphorus.
Phosphorus. Okay, phosphorus has how many valence electrons?
5.
No,
5.
5. So let's just look at those 5 valence electrons. Okay? So, 5 valence electrons. We have 2 and 3s. And we have 3 in the 3p sublevel. Now it needs 5 unpaired electrons, right? So in this case we need 5 orbitals. But with the s and the p, how many orbitals do we have total?
4.
4. Now what's going to happen in this situation? Since the valence electrons are in the 3rd energy level, with the 3rd energy level, we start getting into the d sublevels.
Add 1 and go to 2D or whatever, 4D.
Well,
2.
we are going to use the s and all 3 p orbitals. Then we're going to pull 1 from the d orbital so that we have 5 unpaired electrons. So this hybrid orbital would be called sp3d. So we don't have to put a 1 with it since there's only one d orbital. Okay? Questions? Any kind of questions? Now I can kind of show you this with all of them, but there's kind of an easy way. Remember this.
I like easy way. I like short.
All right. So let's kind of go back to let's look at these 3. So BF3, we said that we had 3 things coming off the central atom, right? the hybrid orbital was sp2. Okay. We had CH4. We had 4 things coming off that one, right? What did we say the hybrid orbital is going to be for that one? sp3. PCl5. We had 5 things coming off that one. We said that the hybrid orbital was sp3d. Now, what do you think it would be if we had 6 things?
sp3d2.
Yeah. So, an example of something having 6 things come off the central atom? SF6. Its hybrid orbital would be sp3d2. Now, what if we only had 2 things coming off the central atom? Example, CO2. We only have 2 oxygens coming off the carbon. Its hybrid orbital would be sp. Okay?
So that's all we gotta write, like in the assignment, all we have to write is SP.
With the hybridization, I'm asking, you look at how many things are coming off the central atom. Now, once again, you count outer atoms, but you also count lone pairs. Okay? So look at your Lewis structure again. See how many things you have coming off. If it has 2 items, it's going to be sp2. If it has 3 items, it's going to be sp2. We have 4 things, sp3, 5, sp3d, 6, sp3d2. Okay, so 2 items, 3 items, 4 items, 5 items, 6 items. Read.
What if we got 2 central atoms?
Okay, so if you have 2 central atoms, you're going to have to look at them individually. Okay, good question.
So in that case, you'll have 2 different of
Yep.
these kind of structures.
Yeah, you'll have 2 different hybrid orbitals, because since we have 2 different central atoms.
That's really easy.
Okay, questions? Any kind of questions?
How about group analysis?
Oh my. Okay, so go ahead, figure out the hybridization. You can go ahead and turn off the video, please.